So I will start with what has been there, which is the bullet points. This is the photo that you take in the panel. What I'm doing here? Why I'm here? Well, that's the whole point, right? The digital distributed manufacturing, it's a concept that I saw in a slide a few days ago. Then when I say open platforms versus metaverses, omniverse, AR, VR, it's essentially open versus closed. And that's the concern that in some way I mentioned on my talk at the beginning about, okay, we are building these massive simulations or digital twins or whatever the name, but the more complexity that we add on top of that, the further are we from black boxes. So every time they integrate or create a standard or something, okay, we leave that there, and we build on top of that. Is that a good thing? Who is taking care of what happens there? That brings me to the supply chain challenges and scalability, interdependency, which again, every time that we integrate some infrastructure or system with another, is there any sort of standards that we match? And who is checking that? Who is policing that? Business and industry challenges and software and system for the enterprise in a complex world is just consequences towards more applications. And everyone has been making quotes, so I picked that. So how do I do these panels? I set out some bullet points, and then I ask friends to submit comments, and then I mix them. I've been running very low on time, so the mix is a little bit more chaotic than usually. But these two quotes are good. All models are wrong, but some are useful. It's been around for some time, that quote. And the only difference between theory and practice is that in theory, they are the same. So the question is, what are the constraints on algorithmic and non-algorithmic computer-based modeling and simulation of real-world challenges and opportunity? So essentially, the discussion that in some way Karen presented, we can talk about digital twins, but what happens underneath? Or when we move forward, or a high-level comment, she won't take a plane designed by someone who did a digital twin without all the checkings. So should I ask you to start, Karen, please?
No.
Okay. Should I order you to start?
Well, I think I had enough to say yesterday, but your question, Nicholas, what are the constraints?
Can you turn the microphone on?
This
Hello?
should be all working. No, that's one.
Maybe there we go. All right. I said I think I had enough to say yesterday, but maybe let me just highlight a few things. You asked the question, what are the constraints to making digital twins a reality? So for sure, one of the constraints is our ability to share models, data and decisions across stakeholders. Because if we think of any of these grand challenges where we're talking about digital twins, it's very rare that it's going to be owned by a single entity, a single company. And that notion of sharing is just a very, very difficult one. The question of who owns the data, where are the handoffs, how do you ensure interoperability across different parts of the system that are owned by different people, where does liability rest if things go wrong, the issues of privacy, and so I think that's a huge one. And of course, much of the challenges associated with that are organizational and social and political and legal, but there's also really interesting technical questions about how we maybe approach this problem from a federated standpoint, where you could think about doing things on different parts of the system without necessarily having to share the data or the models. But I think that's one massive constraint. Mm-hmm. And then I'll mention just a second one, which is our ability to show successes and deploy things before maybe they are really perfect. And of course, they're never going to be perfect. And a lot of that has to do around our ability as a society to tolerate risk. And if I go back to the example that I started with yesterday, which was the Apollo program in the 1960s, I mean, you just think about what appetite there was for failure, and without failure you don't learn, and that's something that's really changed. And so I think that's another very real constraint. How do we get digital twins out into the world having the impact? Let's just pick one. Let's pick the medical example where we really could be improving outcomes for patients, but the bar to actually being able to get deployed is so high, and society's tolerance for failure and learning from failure has really, really shifted. So I think that's a second constraint.
Please, Yvonne.
You have to disagree, remember?
Of course. So I would like to continue to Karin's explanations and arguments. I'm just wondering why, but we didn't talk about the costs of developing digital twins and the energy that you need to build a digital representation of an entity in silico. And as far as I understood, the digital twin can be very coarse-grained, but also very fine-grained in terms of representation of the physical environment. So my question is, and what I would also like to put on the table, how to estimate or how to calculate the right size or accuracy of the digital twin, that it's worth to be represented in silico, that it makes sense. Because what is the danger of end up in a system that is totally intrusive, means the management of the system costs more than the benefit that you have of that system. So I think that's one of the points that we might have with digital twins, and I didn't hear anything about that yet. That's the one point. Another point is I had a discussion with you yesterday, Karin, in the break. Who is using digital twins? I guess non-computer scientists, right? So, and what I've heard yesterday, we have quantization of uncertainty, and we have super complex systems. What do the end users want? They want to push the button. Mm-hmm. They want an app. It has to be something easy to understand, something to use in an intuitive way. So I'm just wondering how we are going to build the interfaces to the end users, whoever it is. And probably in 99% of the cases, they are going to be non-computer scientists. Okay, you are lucky you have you have scientists, like you are building digital twins of the airplanes. You have engineers as end users, right? Right. But if we are talking about agriculture, they are not. So I'm also wondering how the interfaces to the end users are going to look like. It seems to be non-trivial.
And that's why I invite David to answer, who is actually working on those interfaces.
I think probably the most interesting thing from my perspective is I think there's a big gap between what we perceive a digital twin as and what digital twins are in practice right at the moment. So one of the most popular digital twins is probably things like Google Maps. If you have a digital representation of existing data that's being captured and used to control systems in real time, those have existed sort of since the 60s in sort of industry and manufacturing. And, CAN bus protocols, serial protocols, you've got formats that sit on top like tabs separated in CSV and the XML, JSON, etc. And then on top of that, you're laying ontologies. So you're trying to send structured data used to control systems in real time. And I think that's very separate from this, healthcare, designing CAD style. I'm designing things. I'm creating a digital twin because I'm trying to simulate the weather. I'm trying to simulate something that I'm trying to manufacture. And I think what's interesting is that a digital twin, as I say, spans those two things. It's copies of things we know and measure about the real world, and then the simulation aspect. And I think the idea of bringing those two things together is really intriguing. We talk about the data we capture. A lot of the problems that my company's dealing with is capturing crazy amounts of data that is now possible. Extracting from that data the small number of values that are currently being used by the industry to act as the metadata against the ontology for that digital twin. So, for example, if you're doing IVF for cows or for cattle, you traditionally will grade an embryo by eye. So a human will look through a microscope and give it a grade between 1 to 5. So the request is, if we capture all this amazing imagery, can we do a better job of grading embryos? But in reality, we really want to build a digital twin of the morphology of the dividing cell and what the outcomes are. And the reality is the model that we end up creating, the digital twin we end up creating, will be much more sophisticated than 1 to 5. And I think there's a huge amount of research to go on both sides, and the scale of the understanding and the amount of science, the amount of thinking that needs to go to make it practical, so someone's just pressing a button on an app, is enormous. I think there's a lot of work and a lot of collaboration, a lot of standards to be established. So.
The reason why I invited the panelists in trying to bring together a collection of skills. So Paul, he comes from the really low-level open source world and then works for Meta, which is trying to make us all live in the metaverse. And Laura, well, she's a mathematician, which is the challenge that I am trying to present here between, and we all keep repeating the word digital twin, which becomes just, I don't know, buzzword. So I want to invite either Laura or Paul to continue, and from there we go. Should be working. No, it's not. Why is it not working? Is it not working now?
Does it work now?
Yes.
I guess I just have a short comment, and it has nothing to do with math. It actually comes from my previous background in visualization of simulation, and it's the question of provenance of digital twins. I guess what occurs to me is, how open are you going to make it? In other words, do you have a very closed system providing data for the digital twin, and you have one issue there? Or is it a rather open system, you're getting data from a bunch, it's informing your digital twin from a bunch of different sources? How do you evaluate that? How do you deal with discrepancies? How do you deal with, how much do you believe from each source? Because there's always some issue, we all know that. Even like the example you were giving of oncology, well, you've got user issues. Any medical test can have issues of interpretation, and I'm interested in how do you establish a chain of provenance, and how do you deal with that?
Paul, do you want to take that challenge?
Okay, this one looks like it does something anyway. I'm going to break tradition and agree with a number of things. I think that cost matters. I think that risk matters. I agree that usability matters. So I'm going to state the obvious. I mean, you'd apply this where the risk and cost are already high, all right? Where you can say, all right, if we do what we're doing, you have this much risk. If you add this in, it can't increase the risk. You want to make a one-sided bet. So for example, if you have, I'll use avionics because you started first, and I'll say something probably stupid and you can disagree with me. But if you have a situation where you keep your current maintenance regimen, but add to the digital twin, then the digital twin only tells you when something is wrong when you wouldn't otherwise have thought. And in that case, you can argue, possibly fallaciously, but you can argue that all you're doing is making a one-sided bet where the digital twin can't break anything, but it can reduce the risk. In other words, if it reports things are okay, you ignore it. If it reports there might be a problem, then you change the maintenance schedule. I'm going to also disagree with you. I already agree with your cost and risk, but so, computer people do have digital twins. We call them reproducers. And sometimes we work really, really, really hard to get a digital twin of some person's computer out, Lord knows where, that's failing in a really strange way. Mm-hmm. It's a little bit different in that we don't necessarily always have the feedback. The feedback may be manual. I made it do this, what's yours look like? As opposed to having a direct connection, but the direct connection approach has been around for a long time. They were using phone lines in the early 90s to monitor some types of systems, although the digital twin was rather minimal in that it just kept track of things as opposed to modeling the system. So,
so where are we going? Because I mean, in the technology industry, we have buzzwords decade or year after year.
we're going to make up new buzzwords, of course.
Yeah, well.
Oh, sorry.
Do you want to talk about blockchain, for example? My point.
Well, you definitely want your blockchain on your digital. Never mind. Anyway.
My point is, Singapore boasts its own digital twin for an entire city. So maybe, what does it mean? It's just a visualization, it's something. There are people who are getting funded to building reproductions or this and that. What are they actually doing? Maybe I should ask the floor, have you used, are building, are considering, what's your exposure to either modeling, simulations, digital twins? Because I'm old enough to be dabbling on Second Life. Remember that? OpenSim, those sort of things. And suddenly, so to the floor.
Nicholas, you said we had to disagree, so I'm going to disagree with you.
Please.
I mean, maybe it's a buzzword, maybe it isn't, but even if it is a buzzword, it's more than a buzzword. It's a way to communicate what it is that computing can do for the world. And good luck explaining to a decision maker or a politician that I've got these supercomputers, I've got these edge devices, there's some feedback, I've got data, I'm going to do data assimilation, and some uncertainty quantification, right? That is just not the way to communicate to people the impact that computing can have on the world. And so whether it's a buzzword or not a buzzword, it's a way to communicate to the non-experts a vision. And yes, you have to separate that from the people who jump on that vision and say, oh, look, I already have one, here you can come and buy it, or we already have one, because we all know that that's not true. But the notion is it's really important, because I think, and you know, to follow up on Doug's talk, one of the reasons that I think ECP has been so high impact is that this notion of an exascale computer is one that the politicians in the US can grasp on, and the notion of having the first exascale computer and having it before other nations in the world is something that people can get behind. And that is so incredibly important, and I think it's something that we as a technical community don't necessarily do well. So I am all for calling it a digital twin. I mean, yes, we can go into our technical conferences and debate about what we can and can't do, but having it as a vision that we can get people behind, I think, is really important. And if we ourselves call it a buzzword, we undermine that. So please don't. Okay,
I will continue on that, because if I go and say, yes, supercomputing, complex modeling, please fund me. What are you doing? Well, it's essentially a digital twin. Oh, but I already know these guys which are already doing it. And then I enter in the same situation. How do I explain those guys which are doing something which is shallow, fragile? Those are, in my humble view, the two sides of the coin. So, Laura?
I'll just back you up on that very strongly. From the point of view of Viz, which I used to do, stakeholders need to understand what it is we're doing. It's important on a national, international level, and they are not going to, that's not their business. They're not going to follow the math, nor should they. But they should understand what's happening. And so good communication is important. And I agree with you that digital twins also is a means of saying, well, it acts the same way, and you can see this. In terms they can understand. It's important.
David? Oh, no? Yes, Duncan. Yes?
It's alive. First of all, a disclosure, I had something to do with some of the phrases up on the screen in front of us. There was, after I wrote them, I thought actually there was another aspect of modelling that I wanted to introduce, and I just wonder if the panel would like to comment on this. An approximate answer to an interesting question is much better than an accurate answer that is entirely wrong. So part of our duty when we provide results of simulation and modelling is to convey the assumptions and constraints under which we have produced the answer. So you will recall my talk yesterday, I did give a slide about that. And another part of the communication is to give some sense of the degree of reliability or accuracy that you ascribe to your messaging. And that can be difficult in a political arena where politicians are looking for a single point answer or a simple message. And when, for example, here in Aotearoa, New Zealand, when the COVID modelling groups provided answers or predictions that varied widely from a single point answer, the public simply couldn't cope. So somehow there has to be a means of communicating a range of likely outcomes. This is all part of, in business language speak, which I have a fair bit to do with, 3 types of analytics. There's the descriptive analytics, which tell us a bit about what's happened in the past. There's the proscriptive analytics, which tells us a bit about what the future might hold for us. But then there are prescriptive analytics, telling us what to do. And the prescriptive come out of proscriptive. So prescriptive analytics, you must always communicate to the decision makers the assumptions behind your analysis and the likely range of outcomes. So
now disclosure, you work for the New Zealand government.
That is true, yeah.
In your capacity, how often do you experience that situation?
Well, I always make a point of trying to communicate to the decision makers the assumptions and the constraints and the likely range of predictions, if you like, that inform the prescriptive messages that we provide.
Which is an interesting point both for everyone. As a politician, which I'm not, but like everyone who needs to take a decision as a manager, at some stage you need to balance things. And politicians take decisions. I mean, the easiest example is, okay, I need money to build a mega model. Yeah, but how many hospitals can I build with that? That kind of very simplified situations. Or you experience something like that?
Yeah, I mean...
Microphone, please.
We have one of the larger digital twin deployments in hotels all around the US and Canada, and it's designed for staff safety. So it essentially allows a staff member to be located if they're in a difficult situation, and you can imagine that's it's a very important part of that contract to give the hotel and the staff confidence and clear confidence around the measures with which you'll be able to determine their location inside a 3D volume. And what's most interesting about that is that guidance we've provided has changed essentially every month for the last 4 years as our model has gotten better. So even though those properties were scanned potentially, 5 years ago, the accuracy and the improvement to the systems have continued to increase. So it becomes particularly complicated when algorithms and computation and the cost at which you can do that change. So your guidance changes irrespective of the physical technology you're deploying, because you're changing it at a software layer. So I think it's an extremely important part of any discussion. And broadly, the topic that we've been, I guess, talking around with digital twins is that I think the challenge is that I don't think it's necessarily a buzzword. It's a label that describes a whole range of different things, and that's where people come at it in a confusing way. Is it command and control? Is it simulation? Is it metadata on an ontology against a CAD system or a building information management system or a vehicle management system? So I think they're all very different under the same label.
Yes? Go Paul.
I actually have to disagree, and I apologize, but the most important decisions in my life, I've got the benefit of both. I have inaccurate answer to the wrong question. Isn't that a status quo for most people, really, when you think about it?
Don't disclose your humanity.
How's that again?
No. Ivona, you were...
Yeah. Thanks to this panel, I just realized that I'm doing research in digital twins. I was not aware of that. And I have to tell you about that. We are developing a digital representation of the river in one of our projects, where we collect continuously information about the river, about the substances that can be found in the river. And all characteristics of the river, like viscoelasticity. The reason is that in Europe we have often leakage of toxic substances in rivers, and they are just not noticed by no one until someone see that there are dead fishes in the river, and it can take ages until someone noticed that. So we want to automate this type of processes and detect it within minutes, right? And what I also want to emphasize, I mean, it's not just, when you have digital twins, it's not doing things better and having better performance for 10%, 20%, 50%, but you do things that you cannot do otherwise. And this is the case here. Without having the digital representation of the river in silico, you cannot detect certain substances. You have to observe continuously to have micro fingerprints of substances that might be potentially in the future in the river. Exactly what you were talking about, Duncan, right? So thank you very much. There is another buzzword that I can put into my CV.
So, Karen, you keep defending the... No, Laura, I'm interested on the underlying, not sure if I wrote it, the constraints of algorithmic, it wasn't my words, non-algorithmic computer-based modeling. How standardized is the axiomatic or topology definition for a simulation? Are we taking just a standard math and go and build on top of that? Or using Omniverse as an example, are they doing some black box definition of geometry or distance and with the expectation that the rest of the world will follow? I mean, if you read the history of a company called Esri, E-S-R-I, a guy just decided that this is how we're going to measure, and that was in the late 60s, and then they built a company on top of that. And this is a company that I learned more recently, Bentley. They are selling digital twins worldwide. You certainly can help me on that. And essentially, they just grab a piece of the market because no one else is watching. And they go through it. I mean, in high tech and in innovation, we do that all the time. And all of you have been exposed to something like that. It was called Windows. So that's my concern, going back to the original point of agri-tech. At some stage, someone is defining, and let's use John Deere, they are big enough to don't give a damn about me. Let's use it as, I mean, they are just grabbing everything. And someone told me, actually it was Lucy that I saw the data in your webinar, that 50% of farm data is already owned by, let's say, half dozen of the large companies. And Syngenta is particularly owned by the Chinese government. And it's not being paranoid. It doesn't matter if it's Chinese or Zambia. These things move in one way, and at some stage you say, hello, can I do this? And if in a bigger picture, let's talk about money. All of us use Visa and MasterCard. Sometimes use Bitcoin or something like that. But, I mean, you see where I'm coming from? One thing is to play with our money. Other thing is to play with operating system. Playing with our food, that's a maybe philosophical concern, please.
I guess just going back to the point about the Omniverse, for example. So as a collection of different, I guess, standards, I mean, it's interesting. One of the particular aspects that the vendor is very confident about, for example, is the ability to act as an interchange format for 3D content. So you can take assets like proper CAD files, you can tessellate them into essentially a GTLF mesh, and then you can, you know, transfer them across a network, have a nucleus server that has this thing called Fabric, which caches it all. So on different devices, you can view level of detail views into very complex scenes. And that's an important part of engineering that otherwise other people would have to do. Is that exciting from the perspective of, if we think of the overall heading of digital twin? I mean, it's useful because I can visualize 3D models, but it's not necessarily achieving any of the goals that we've talked about. It's just part of a bigger puzzle. And I think, you know, that's definitely the challenge, is you've outlined probably 6 or 7 completely different tangential aspects to what is essentially representing real things in a digital model. And I think perhaps the biggest challenge is that those digital models continue to change and improve. They're being worked on by lots of different people, and all of those different things, whether it be the computation, the compiling, the simulations, we need to be able to work together on those things, and combining the chips and chiplets, whatever it might be. More the ability for more groups to work together and be able to share their data. One of the challenges is that data. What's the accuracy of it? What's the provenance of it? How's it been ascertained? How regularly is it updated? How real time is it? I mean, there's just tons and tons of challenges under the heading of digital twin.
Well, we constantly have standardization issues. One of the panelists that couldn't make it today, Mark Thomas, who has a company called NextSpace, and hopefully he will be here tomorrow. His talk is about ontology. Now, we can have different versions of ontology, but what I remember when I had a chat with him is about, okay, you have an element, and then that creates information. Now, each of them are attributes. You consider those attributes as points of entrance if you want to build a digital twin for glass or evaporation or whatever, but there are always the same attributes for that unit of knowledge or something. Now, the challenge that I ask, okay, what happens if I arrive first and then I own the attributes?
Yeah, I've been in lots of meetings where people have argued about attributes for many hours.
Okay.
What's an HVAC and what are the attributes, and who gets to define them and what units they use? Yeah, it's a really interesting problem.
I'm here to learn.
How do you share data? Like, what's the basis on which the cubic feet per second of the HVAC system is calculated, or what basis is it modeled on? So,
and I just make this comment, which brings me to the primary sector. This is my farm and has a number of attributes that I want to share with Fonterra because it's my distributor. But then I realized that John Deere, they already did the harvesting and collected that data, so I cannot share, not even with my local council. So those are concerns that I am looking for good answers. I'm totally open. I want to be, that's why I organize a conference, to learn. Right, so please, Karen.
Yeah, Nick, I think this question of ownership is a really important one, but just sort of coming back to the examples you were giving of people sort of filling into this market space, I think one of the things the digital twin has done is it's made people realize that the digital representation of a system has value itself. And by calling it a digital twin, you give it an identity, and just like the glass has value and it sells for something, now the digital twin also is a thing and it has value, and this is sort of separate from the question of ownership. And so, I mean, I don't know, I think about the history of science and technology and how the entire research and development enterprise, from universities to labs through industry, has been around how do we innovate and put value into the physical products. We as a community, the computing community, should be asking the question, how do we innovate and put value into the digital twins? Because the digital twins really are now products in their own right. So I think it's an indication of a shift, and the shift is that computing now brings value to the market.
Can I just make a very quick comment? Is there a market for non-fungible tokens in digital twins?
Okay, now we are...
Non-fungible twins?
Andrew.
So the coming on that, the point you make about the data being privatized, I would hope that with cheap drones and cheap sensors, the barrier would become smaller over time, but maybe I'm naive.
Mm-hmm. Yes, Andrew, and then Doug.
It's Nicholas's way of keeping you quiet. He gave you a dumb one.
So you've talked... You've talked about communicating more clearly what it is we're doing with simulation via digital twins, but can we make it much easier for ordinary people to use?
So what are you saying? Can I go to a supermarket and buy a digital twin?
Yeah, but if I want to do, if I want, like, I can look up the weather forecast quite easily, right? But if I want to do simulation in quite a lot of cases, do I need a $4 billion exascale computing program to do it, or can I make it more available to ordinary people who might want.
No one has a comment about how to democratize access to technology?
I mean, I think the Google Maps example, I mean, I actually wrote down, is Google Maps a digital twin? It's with a question mark for myself because I haven't thought about it before, but Google Maps, I think, is my favorite of all the Google products. I mean, you think about how much information and how much sophistication is there, the ability to zoom in and zoom out, the layers of analytics that you can put on there, the way you can put, your decision making. I need to go from here to there. And I often use Google Maps as an analogy when I'm thinking about modeling complex systems, because wouldn't it be great if you had a model of an engineering system when you could zoom in and zoom out? And what's really miraculous about Google Maps is that like anybody can use it. It's so well done visually and intuitive. So your question is, can we make it more accessible? Well, we couldn't really make it much less accessible than it is today. But by the way, and we've got to start all the way in kindergarten. I mean, what's going on in the education system in the grade schools it's heartbreaking because we are educating children for a world and we're not preparing them. Just speaking of the US, we're still requiring reading, writing, science and social studies, but computing is not required. And if it's not required and you're a head of a public school and you've got limited resources, you don't put resources towards things that are not required. What are we thinking as a world? How can these very basic computing skills not be required in our primary school education? So resounding yes, we not just can, but we have to make it more accessible, but we have to be thinking about how to do that instead of sitting on our hands, I don't know, waiting for something to drop from the sky.
And actually one Google Maps topic which is very interesting to think about is along with their acquisition of Waze and a number of patents, they collect data from everybody walking around, and one of the amazing capabilities that Google Maps has is to predict how long it's going to take you to get somewhere, what the traffic's going to be like depending on your mode of transport. That's all crowdsourced data they're doing without your, I mean, I guess you've consented to it, but it's all happening in the background. It's pretty amazing. So
it's amazing and could be dangerous.
Yeah, and scary. Yeah, absolutely.
For a number of Doug.
Yeah. Test.
Maybe one explanation why Google Map is so easy to understand is because people are used to use maps already before Google Maps existed. So if there is a product or something that people are already using and then you have a digital representation of that, I think it's easy for them. Yeah, that's for me at least the explanation.
That's a fair point. Yes, Doug.
As I listen, I now have 2 or 3 comments, questions. For Karen, I think my grandkids do pretty well computing, just watched them drive an iPad, but that's not what you meant. And, Waze on crowdsourcing, I'm amazed that it's able to take the data and feedback. I mean, I've been tempted to say, hey, I see a dead body on the road just to see if some bad data will get in there, but it is amazing. Anyway, on the digital twin thing, I agree with what Karen is saying, but I do think that term is abused and overused. 12 years ago, we used the term virtual, so we built a virtual reactor, okay? Or we said we put the reactor in the computer. But I think what's different about what we did back then relative to the twin is the constant feedback. So what we did back then is we'd do some simulations, we'd go compare, by hand with data, we'd go tweak the simulation. There wasn't that real-time feedback. In the 90s, Chuck Farrar in Los Alamos developed what he called smart materials, but that was essentially aircraft wings with sensors embedded that talked back to the base station and say, I'm in trouble, right? So it was sort of sensing. So that maybe was the first of what I would think of as a twin, but I think the twin is this constant communication that's automatic and in real time, and Pete's talked about it with sensors. I think to me that's what is different is these two things are moving forward in time and more in lockstep. And so I think that's a real challenge, is having that constant feedback that isn't sort of human intensive.
And that will democratize the usage, and you say, because I mean, if I am just able to, access, but whatever I do, change that digital twin that becomes mine, or I am the user, I rent it for a week or something, or in your case over the hotels. I mean, I want to know I want to regulate the aircon. instead of calling reception or failing. I mean, all the applications are limitless. I think the twin concept precisely is that the up and down, up and down.
Well, the Google Maps one is a good one because you're interacting with that virtual world and it's interacting with you. So that's a good example.
But
I'll
still,
defer to
it's not
Ben.
Maps, but Google Maps. And that's the question that I want to keep asking. Yes, Ben.
Yeah, I was just going to actually build on something that Doug just said. The term has been abused, and I feel like it has been abused because there's not one definition of what a digital twin is. So I like that you put up a definition yesterday. It was actually a very good definition. But looking forward, when we start talking about what's in the future, how do we avoid these terms getting abused? So what is the future? We've been talking about like systems of systems. So is that the future? So if we have these digital twins, or we have digital twins of digital twins, and how do you connect those digital twins together and look at how they affect each other? And so kind of just open up the door to talk for anybody to have advice on, what does the future look like, and can we give a term definitions early instead of late?
Yeah. So can I invite the panelists to have a closing statement on what we have been talking?
I'll talk about usability. In the past, if you want your stuff to be usable, you make it look like a computer game or like some movie or some other thing that people are familiar with, which can take some time digging through those things. But the other thing you do is just ask a gamer.
I'll talk about usability, also interpretability, and also mention something you mentioned earlier, which is metrics that are used. There are a lot of concepts of distance that can apply to a lot of different things. At Los Alamos, we do CFD simulations. You've got 3D space, and we all understand that. Google Maps, 2D space. How long does it take us to get from place to place? If you're talking about resilience, you're worried about how many bits flip, and you're talking about Hamming distance. And that doesn't really relate well to physical distance. If you're talking about integers, which I've done a lot of work with that, you can talk about, well, how close are two integers? 9 is close to 10. You can talk about which integers divide other integers. So 5 is really close to 50, and it's really far away from 6. And your mental model is how the metric is used is going to, or how the metric is applied is going to speak to how your mental model develops and how you can use the system. I mean, I've gone back and forth with people trying to make one definition of closeness on integers work where really another one is the most important. So metrizability and distance is important, and it really does speak to interpretability.
David.
I think one of the big challenges with digital twins is it's a catch-all phrase, and we do a lot of work with industrial digital twins, and if I was to pick one small example, like the visual representation of the digital twin, one audience wants to see CAD data because they want to know what are pipes, where are the power conduits, what's all the detail because I'm going to be making a new extension to this factory, and a different group might want a point cloud scan because they're going to look at it from the perspective of how people feel in this space and how can we improve the lighting. So one of the real challenges is you've got lots of different data sets, some of which don't even talk to each other. So it's pretty tough.
Ivona, or okay, Karen.
So maybe in the last word, I'll come back to the question of what does the future hold, and so I think, of course, the answer is always it depends. Depends what field you're in, and we talk about digital twins. And clearly it's not one size fits all. So when you look at fields like engineering who have been sophisticated users of computing for some time, and you ask, what does a digital twin hold? Well, so maybe it's taking things to the next level. Maybe it's also a lot of, well, we've already been doing these things, we just didn't call them as such. But it is also taking advantage of new technologies, particularly AI, machine learning, edge computing, and next generation sensors, and thinking differently about our complex systems and our design processes. And by the way, all the way back to design. So I think that's the future in that regime. And then at the other end of the spectrum, just think of all the areas that have not been revolutionized yet by computing. So I put medicine somewhere in the middle. Medicine's going through its revolution right now. And then over on the other side of the spectrum are things like education, social welfare, well-being, issues around poverty. There are so many parts of society that are somewhere between the social sciences, sort of maybe natural, physical sciences, where again, we could really start thinking intentionally about what does sensing look like, what does the data look like, what does the edge computing look like, and what hope is there for modeling, and think about where we want to be as a world in 10 years' time and start architecting that intentionally. And by the way, that's going to take all the people in this room engaging with people that we never talk to. And I just pick on one of my favorite topics, which is education. Oh my gosh, can you imagine what a notion of a digital twin could do for education in terms of helping teachers to scale their attention, particularly in some of the school districts that are most underserved? And again, it doesn't have to be perfect to be better than what we have today. It's such an incredible opportunity, and I would love to see the technical community coming together around some of those things.
Ioana?
Okay. What I think it's going to be quite important, I think it was also mentioned by you, Laura, the definition of metrics. What are the metrics we want to have here, ranging from energy that is used and necessary to build a certain digital twin? What are the costs? What is the benefit? So the clear definition of those metrics, I think, is crucial. And another thing, I just got scared when I started to think, God knows of how many digital twin I'm already part, where I am already. So it's a bit scary for me, right? Because I lose the control of where it's already scary with all the systems that we have right now, but it's going to be even more scary for me because I have no idea what's going to happen with my information about me, my personal information. We are talking about differential privacy and all those things. So I'm really wondering what's going to happen in this area and what are the solutions here.
It's too late because we were talking in the open source community about Google and Facebook, and we always knew, I don't know how many of you actually read the software level agreement, but 20 years ago, of course, Paul, you did, but now we are facing this on 3D. Now the general public is, it's taking my data, duh. So I won't call him a friend, but I interviewed him once, a gentleman called Bin Cerf, who did a thing or two, and he used to say, privacy is an illusion. And that was 10 years before cameras in every corner.
So you're trying to tell me that advertisers keep digital twins of all of us as part of the business model?
I never thought about that. Please join me saying thank you to the panelists for the insights.